Hi there, this is a video for geometry. It is over chapter 4, section 2, and we're talking about angles of triangles in this lesson. And one of the first theorems that we have for this section is a theorem called the triangle angle sum theorem. And basically what it says is that the three angles that make up the triangle add up to 180 degrees. So at all times within a triangle, the three interior angles will add up to 180 degrees. And so you can see from the diagram that we have the measurement of angle A plus the measurement of angle B plus the measurement of angle C equals 180. And so what we're going to do right now is we are going to prove this theorem. And the proof is quite lengthy. I know that we haven't been doing proofs a lot lately, but it is important for us to every now and then refresh our memories and see a proof. And you might have to make a proof yourself in the homework, so I want to make sure that you remember how to set up a proof. Remember that although the book may ask for a flow proof or a paragraph proof, in my class we are strictly sticking with two-column proofs. So I am going to demonstrate a two-column proof for you to prove this theorem. So first off, we have given triangle ABC. So we're given this triangle here, ABC. They're asking us to prove basically the theorem that states that the three interior angles, in this case the measurement of angle 1, 2, and 3, that those three angles added together would equal 180. So here we have our statements and our reasons. We're going to start with our given like always. Given triangle ABC, and the reason for that is, well, it's given. My second step is kind of strange. You might not be used to something like that. But what I've done is I've added to the diagram itself. And I've already done that ahead of time so I can save some time. But I'm adding this line segment here that we're going to call AD. And sorry about that. And you'll notice that it's a dashed line because it's not actually part of the original diagram. But I'm adding that. So I am drawing line AD through point A so that it's parallel to segment BC. So now what I'm showing you is that AD is parallel to BC, and we're going to see why that is important later. And that's due to the parallel postulate. And from here is where we start beginning to add to our proof. So what we can say here is that angle 4 and angle BAD are a linear pair. And I have to abbreviate here because I don't have that much space. Okay, and that is by the definition of a linear pair. Definition linear pair. And I can show that to you here. So angle 4 is this angle here. And angle BAD, angle BAD, extends, remember we talked about this in the last lesson, you go from B to A all the way to D. So it's actually these two angles combined. So if I take this angle here, angle BAD, and angle 4, then they do in fact form a line. So they form a linear pair. That's the definition of a linear pair. And because they form a linear pair, angle 4 and angle BAD are what we call supplementary. And again, I have to abbreviate because I don't have enough space. But angle 4 and angle BAD are supplementary, and that's by the supplement theorem. And we talked about the supplement theorem in chapter 2, section 8. If you want to go back and revisit that lesson, basically states that if two angles form a linear pair, then they add up to 180. And so our next step is just that because they're supplementary, the measurement of angle 4 plus the measurement of angle BAD should equal 180, and that's by definition of supplementary, which we already said earlier that they were supplementary based on step 4. So in step 6, we're going to then also we've kind of exhausted that step there, or that information there. So now we're going to start all over again, and we're going to start with also the measurement of angle bad is equivalent to the measurement of angle 2 plus the measurement of angle 5. So what I'm saying here is that angle bad, which I said earlier was this whole angle here, is basically made up of these two angles added together. So angle bad is equal to 2 and 5 added together, and that is the angle addition postulate from way back when. And it's kind of strange. I'm starting to see that my numbers are not lined up here, but hopefully you can attach 6 and 6 and 7 and 7. And okay, so now we're going to use substitution from step 5. In step 5, we had 4 plus bad equals 180, but we know that bad equals 2 and 5. So we're going to replace bad with 2 and 5. So now we're going to get, if I can write small enough here, the measurement of angle 4 plus the measurement of angle 2 plus the measurement of angle 5 equals 180. I was able to squeeze that in. So I took basically step 5, which said 4 plus bad equals 180, and I replaced bad with 2 and 5 because that's what it's equivalent to. So now in step 7, I get 4 plus 2 plus 5 equals 180. And again, that was substitution. And that's from step 5 and 6. Put those two steps together and you get step 7. Okay, now we also know, because now we can go back and use this 80 that I had here earlier. And what you should note now from before is that we have a pair of alternate interior angles. Angle 4 and angle 1 are alternate interior angles. They have a transversal here, these are parallel. But also angle 5 and angle 3 are alternate interior angles. So in step 8, we're going to say that angle 4 is congruent to angle 1, and also that angle 5 is congruent to angle 3, and that is by the alternate interior angles theorem. And then in step 9, if the angles are congruent, then that means that the measurement of angle 4 equals the measurement of angle 1, and also that the measurement of angle 5 equals the measurement of angle 3, and that is by definition of congruence. And then our very last step is to once again use substitution from step 7 and 9. So in step 7, we had 4, 2, and 5 equals 180. And in step 9, we know that 4 is equivalent to 1. So I'm going to replace the angle 4 with angle 1. I'm going to leave the angle 2. And I'm going to replace the angle 5 with angle 3. And then equal to 180. And that was what we were trying to prove in the beginning, that 1, 2, and 3 added up to 180. Angle 1 plus angle 2 plus angle 3 equals 180. And so that's going to be substitution. And it's from step 7 and 9. And then of course when you're done with your proof, you put your little helmos for your little extra credit points there. And there you go. Now, that is one crazy long proof. So what I'd like to show you also is another way that you can look at this, another very visual proof, if you will. Here I have a triangle, and this triangle has marked, and I hope you can see them, angle 1, angle 2, and angle 3. And what I'm going to do is I'm going to tear off the angles, just like that. And then we're going to put these angles over here. I'm going to strategically place them over here. And what you can see is a very visual proof of the triangle angle sum theorem. If I take those angle measures and rearrange them, you can now see that they form a linear pair, which means that angle 1, angle 2, and angle 3 should add up to 180. And that was a much simpler proof. Just a visual for those of you that like to see a visual. So either way, with the long proof or the informal proof that I just showed you, we get the triangle angle sum theorem. So in our first example, we want to try to use that in this example here. Now there's a whole soccer story behind this example, but the main part is the fact that we have this diagram, we have this given information, and they want us to find the measure of each numbered angle. So right off the bat, it's going to be really simple for us to recognize that angle 2 is a vertical angle with 78 degrees. So I know that the measurement of angle 2 is 78 degrees. That one's easy. And then I can use the triangle angle sum theorem that tells me that the measurement of angle 1 plus the measurement of angle 2, which we just said was 78 degrees, plus the measurement of angle 3, so 1, 2, and 3, so this one's 61 degrees, should all equal 180. So when we take the sum of 78 and 61, we get 139. And if we subtract the 139 to the other side, 180 minus 139 is going to give us 41. So then we have angle 1 is 41, angle 2 is 78, and the only one that's missing is angle 3. And like we did for angle 1, we can state that 20 degrees plus 78 degrees plus the measurement of angle 3 should equal 180 as well. These three interior angles here should also equal 180, and 20 and 78 is 98. So if I subtract 98 from both sides, then the measurement of angle 3 is equal to 180 minus 98, which is 82. So that's how I find the three values of my angles. So now in this do-it-yourself question, we want you to find the measures of each number angle for part A and for part B. And then we will move on to the exterior angle theorem. And this is our second theorem in this section. Really simple theorem. But before we can talk about the theorem itself, we want to make sure that we have some vocab down. What we have here is a triangle ABC, and the inside of the triangle is shaded like an orangish color, and then the outside of the triangle is basically the exterior, which is the green portion. So all this stuff out here is exterior, but not everything out here is actually an angle. So the only angle that we see labeled that is outside of the triangle is this angle right here, angle 4. So we have over here exterior angles, angle 4. An exterior angle is formed by an extension of one of the legs of the triangle and then a side. Okay, so for example, if I were to add or extend BC like so, if I were to do this, the angle that I'm looking at right here in this area is not an exterior angle, because this angle, although it is an angle, this angle is formed by two extensions from the triangle, and that's not an exterior angle. An exterior angle is only formed by one extension, and the other side of the angle is a side of the triangle. So over here, this angle would qualify as an exterior angle because it's formed by a side of the triangle and an extension of the triangle. Side of the triangle, extension of the triangle. So just to be clear, exterior angle has to be formed by an extension of the triangle and a side of the triangle. Then the interior angles, and I should clarify, the interior angles are all three of them. Angle 1, 2, and 3 are all interior. But what we want to say here is not interior, but remote interior. And when you think about the word remote, it means far away. Like when you want to turn on the TV, use a remote. Why? Because you don't want to get up and go up to the TV and turn it on. You want to be a distance from the TV and turn it on. So remote means that you're a distance away. So if this is our exterior angle, then the remote interior angles are the two angles that are not close to angle 4, that they're not next to angle 4. So angle 2 automatically does not qualify because angle 2 is right next to angle 4. So this is not considered remote. So the remote are the ones that are farther away. So angle 1 and angle 3 are the remote interior angles. So the exterior angle theorem, now that we have all the vocabulary down, the actual theorem states that the exterior angle, so angle 4 in this case, is equivalent to the sum of the two remote interior angles. So the sum of 1 and 3 together. Notice that angle 2 doesn't play a role in here. It's the remote interior angles. The sum of the remote interior angles is equal to the exterior angle. And we are going to prove that as well. And this proof is not as hard as the previous one. It's a little shorter and a little bit easier to understand. So here we go. We have our diagram here. You can see that basically what I've got going on here is angle 1 is the exterior angle. It's formed by an extension and a side. Angle 2 is not a remote interior angle because it's right next to angle 1. But angle A and angle B are the remote interior. So what we're trying to prove is that the sum of the remote interior, A and B, is equal to the exterior, angle 1. So here we go. First, we're given triangle ABC. That's obviously given. And the other thing that I've already written down is that from the previous theorem, the triangle angle sum theorem, which is triangle angle sum theorem, we know that angle A plus angle B plus angle 2 is equal to 180. And that's just because of the triangle angle sum theorem. So now, we also know from the diagram that angle 2 and angle 1 are a linear pair because they form a line. So that's definition of linear pair. And then in step 4, because they're a linear pair, that means that angle 2 and angle 1 are supplementary. And this looks a lot like our previous theorem. We had the same kind of situation happening there. And again, we're going to base it on the supplements theorem. Got to abbreviate here. And again, that was from chapter 2, section 8. The supplements theorem. If two angles are supplementary, if two angles form a linear pair, then they're automatically supplementary. All right, and so then because they're supplementary, we can state that the measurement of angle 2 plus the measurement of angle 1 equals 180. And then that's going to be by definition of supplementary. Okay, now we're going to use some substitution, and we're going to use those from steps 2 and 5. So in step 2, we knew that A plus B plus 2 equals 180. And in step 5, we know that 2 and 1 equals 180. So since this equals 180 as well, we can replace this 180 with 2 and 1. So let's hope that this fits here. So what we're going to say is that angle A plus angle B plus angle 2 equals angle 2, up, and it's not going to fit, plus angle 1. So unfortunately, I kind of had to drop down here, so we're going to have to bring this 7 a little further down. Alrighty. But basically what we're doing is, since this equals 180 and this equals 180, then they should equal each other. So we've got A plus B plus 2 equals 2 plus 1, but I had to write it down here. And that's going to be substitution. And it's from steps 2 and 5. Okay? And then finally what we're going to do is, you'll notice in this step 6 that both sides of the equal sign have an angle 2 in it. So if I subtract angle 2 from both sides, it's going to cancel on both sides. So I'm going to be left with the measurement of angle A plus the measurement of angle B on the left. And then this angle 2 and that angle 2 will cancel, leaving me with angle 1. And that's by subtraction property. And of course, that's the end of our proof. So we put our little helmos. And again, that's what we wanted to prove in the first place, that the A and B were going to equal to the 1. So that is a proof of the exterior angle theorem. And now we will use that theorem in example 2 to practice. Alrighty? So it says here, find the measure of angle JKL. And here's JKL. And JKL happens to be an exterior angle. It's got an extension and a side. And so we know that this exterior angle, which is 2x minus 15 degrees, should be equal to the two remote interior. And the remote interior are angle L and then this 50-degree angle, because this angle will be the next two angles, so it's not remote. So 2x minus 15 should equal x, the sum of x and 50 degrees. And once we set up that equation, we can just solve it for x. We'll subtract x from both sides, add 15 to both sides. 2x minus 1x leaves us with 1x. And then those cancel, and 50 plus 15 is 65. And just like that, x equals 65. But they actually want the measure of JKL. So the measurement of angle JKL is equal to 2 times x. So 2 times 65 minus 15. And 2 times 65 is, I think, 130. And then we're going to subtract 15 from that, and you will get 115 degrees for the measurement of angle JKL. And that is our final answer for that guy. And so now we would like for you to do this example, do it yourself, number 2. It says find the measure of angle 1, which is right here. It's an exterior angle. So then we go to our last concept for the day, and that is the triangle angle sum corollaries. Remember that corollaries are basically theorems that are one-liners. You can add them to an existing proof and then prove them as well. So we're not going to prove them here, but they follow directly from the theorems that we've already had earlier today. And there's 2 of them. The first one, they should make sense. The acute angles of a right triangle are complementary. And that's because if you know that the 3 angles in a triangle have to add up to 180, and if one of those angles is already 90, then the other 2 angles have to make up the other 90. Hence, complementary. The second one says that there can be at most 1 right or obtuse angle in a triangle. And again, because if the sum of the triangle has to be 180, and if you already have 90-degree angle, you can't have another 90-degree angle and still be considered a triangle, because there has to be 3 angles, and so 90 and 90 would already be 180. There would be no room for the third angle. And same thing with the obtuse one. If it was bigger than 90, like if it was 100, then you wouldn't have another obtuse angle, because then they wouldn't add up to 180. You would surpass your limit on the 180 situation. So anywho, we have those 2 corollaries. And so based on some of that, we have an example here. This example, we're using the same diagram for both the example and the do-it-yourself question. It wants us to find the measures of each numbered angle. I'm going to do angle 1, and then you can do angle 2, 3, and 4 for the do-it-yourself, and then you'll be done here. So angle 1 is right here, and as you can see, we have a right angle. And so I know from this guy that the other 2 angles, angle 1 and 52, has to add up to 90 because they have to be complementary. So what I'm going to do to find angle 1 is we're going to say that the measurement of angle 1 plus 52 degrees has to equal 90 degrees because it's a right triangle, so the other 2 acute angles have to be complementary, have to add up to 90. So I just subtract 52. And the measurement of angle 1 is going to be 38 degrees. Alrighty, now that I found that one, you need to find A, B, and C for do-it-yourself number 3. Once you've done that, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.